Hello everyone, this is Sean, and today I'm going to give you a brief lecture on structural modeling. Now, structural modeling is a key step in designing a system. It helps determine the classes, the methods, and some of the inheritance relationships that you're going to use in the system. And this kind of planning is key. Planning ahead of time and mapping out the different types of classes, the different types of objects, and the associated methods that are going to be used really will save you a lot of time in the long run when developing a system. Especially, like I was saying, in larger systems where there's a lot of interconnecting parts, this work up front, this planning and diagramming ahead of time saves a lot of trouble and a lot of time during the implementation phase of a system. So without further ado, let's get into the discussion. So the objectives, what we're going to talk about today, is to help you understand the rules and style guidelines for building these diagrams, the CRC cards, class diagrams, and object diagrams, how they work together to create the structural model. So hopefully by the end of the lecture, you'll be able to create the CRC cards and the diagrams. And also, it helps understand the relationship among those different structural models. The relationship between the structural and functional model is a little less clear, but I think it'll make more sense when you actually see the class diagrams and the object diagrams and what they are showing versus what a functional model would show. So then the question is, what does a functional model show? A functional model shows the structured representation of the functions of a system. So in other words, the things that the system does, the things that you expect it to be able to do, why you built the system in the first place. That's a functional model. The structural models, on the other hand, are representing the objects in the systems. So, for example, the people, the user, the customer would have an object generally in a system. If you think of the patient appointment that was in the book, the patient would be one of the people. The receptionist would be a person. The doctor would be a person. Those are the objects. That is what the structural model will be representing, those objects and their relationships between each other, how they interact. You can think of objects as the nouns of a model, people, places, and things. So structural models are drawn using what we call an iterative process. Any new problem is approached this way. So you start out essentially at a very high level saying a person is going to walk in and make an appointment. And then as you start refining, you get more detailed. You say they need to fill out a form, the receptionist needs to enter them into the system, they need to fit into a schedule, and so on. You get more and more detailed with the model, and eventually you arrive at this is the stuff that needs to get implemented in the system. The other thing it does is it creates what they call a vocabulary for the analysts and the users. So in other words, it allows you to show and communicate the things that this system is going to do, both from your perspective and then the users who will be actually the ones using the system will be able to look at it and then give input also as to whether everything that they need is implemented in the system. So really the main goal, as it states here, is to figure out the data contained in the problem and then use basically a structural model to then give us an idea of how we are going to design and implement these programs. So the classes, attributes, and operations, these are the terms that we're going to be using to define essentially the object-oriented programming equivalents of classes, properties, and variables, and then methods for operations. This box here on the left is how you would in UML generate a class where you'd have the title at the top, the title of the object at the top, the attributes or the main some of the variables, the properties, and then the third box would be the methods, the operations, the things that you can do with those classes. The other thing that the UML diagram will show us is how the classes relate to each other. So there's essentially three types that we're going to deal with. There's generalizations, aggregation, and association. Generalization, they say a kind of, I like to use the term is a. So for example, a dog class. A dog is a animal, is a kind of animal. And so the dog would be the animal class is a generalization of the dog class. The dog would actually inherit a number of attributes from the animal class. That's generalization. That's how that translates to programming. Aggregation is more of a has-a instead of an is-a or a kind of. So, for example, a house class has a bunch of room instances. So you could say that aggregate number of rooms equals a house, or a house is made up of a number of these instances, these room instances. And then for association, that's more of a catch-all for everything that doesn't fit under generalization or aggregation. Usually, it's some weak form of aggregation. And an example they give in the book, which is a good one, is of a patient and appointment. So a patient has a relationship with the appointment time and the appointment itself, but it's not really, patient is not made up of appointments, and appointments are not made up of patients. And so it's not really an aggregation relationship, and there's no inheritance going on, but there is a relationship that needs to be captured. Usually, this means that one of these objects will contain an instance of the other object. So an appointment will contain an instance of a patient object with all the relevant information, that's involved in the patient object. Now, before we can create any of these structural models with all these objects, we need to identify what these objects are. What are the things that we are going to be modeling in our system? So there's different ways to do this. The first that they mention is a textual analysis of the use case information. What that means is essentially looking at a use case and determining what are the nouns, what are the things that are in this use case. So if we think of an ATM as an example, what are the nouns of an ATM? Well, there's going to be a customer, there's going to be a bank, there's going to be the ATM itself. There may be cash, that might be considered a noun. And so you use textual analysis like that to come up with the types of classes. Also, the verbs would then suggest the methods, the operations, like a transaction. If a user is making a transaction in the ATM, are they depositing? Are they withdrawing? Are they transferring? These are all different operations that you might need to model in your system. And so this essentially gives you a rough cut. This is like an early way of coming up with things that could be candidates for being objects in the system. And on the next slide, there's a table of textual analysis. I'll go over a couple of examples. The second thing they have listed here is brainstorming, which is more traditional. Get everyone in a room, sit down, and just start coming up with anything you can think of that may be an object. And you start out with objects, and you just come up with all sorts of different objects. Don't delete anything. Don't remove anything. Don't say, no, that's dumb. Just throw it up there. You can always ignore it later. You can always cull it out. And then do the same thing for attributes and operations and relationships once you have that initial list of objects brainstormed. So here's a list from the book of different possible textual analyses. So a common or improper noun would be a whole class of objects. For example, a person object would be like a generic person object. That would be an example of the first kind. For the second, a proper noun, as in a person's name, John. Well, John is a customer. So the common noun would be person, would be the parent class. Then the proper noun would be the subclass of that, customer. And then a collective noun, those customers, might be an array of customers. It might be storing a list of all customers or something. An adjective would be implying an attribute of an object. So the John is waiting. That's a verb. John is tall. It might not be an attribute that you're going to want to use in the ATM example, but John would be tall. That would be an example of him. And then that attribute would maybe be his height. It would be an integer in inches, something along those lines. A doing verb, like the waiting, which I got ahead of myself there, would be an example of an operation, of a method. So maybe John is waiting, or maybe John is withdrawing, or depositing, or something along those lines. So that's how that works. So you go down the list, and you can see all the different kinds of comparisons that they have. We'll get into relationships in just a few minutes. So you can take a look at this in your book when you are going through and trying to come up with objects and methods and so on for your systems. So another couple ways that they have for object identification would be a common lists object. Now this is something that can be ongoing. Common lists would be things that are often used in a business system, like a customer, for example. that is, a customer is going to be a common thing among all your systems if you're working for a business. And so you may have this long list of common objects, and it's something that you can create and generate and add to as you go along from system to system. As you create different programs, you may end up reusing a lot of these common objects. And it's not just physical things, it's also incidences like use cases, roles, like a person would be an object, a customer would be a role, a manager might be a role, an employee might be a role, things like that. And then interactions, of course, between them. The last one is patterns. Now, patterns is useful for simplifying these diagrams and basically creating common groups of classes that are reusable. So, for example, you could have a transaction pattern because there's very often transactions that occur in these systems, and that transaction could be used for an online transaction, an in-person transaction. It could be for goods, it could be for money, it could be trading things. But at the end, you're still going to have a core group of objects in this pattern. You're going to have someone who would be buying, someone who would be selling, or basically two parties who would be exchanging something, and then the items that they would be exchanging. So that would end up being a pattern in itself. So once you've come up with a list of the objects that you would be using, you come up with a good number of the operations that they'd be performing and the attributes that they'd have, then you can start actually writing down these ideas that you have in a structured way that we're going to start using to develop the diagrams and create the full structural model. And so the first step would be creating what we call CRC cards. A CRC card is basically index cards, and they are printed on index cards front and back. And they give information about the object. They have a class, the responsibilities, and the collaborations. That's what CRC stands for. And so you end up having is an index card, and there'll be some examples in the next slide, that gives that information. It gives the name of the class, it gives the type of the class, if it's concrete, if it's abstract, and then a description of what it is, and then the responsibilities. What does this class do? What is this class responsible for? Sometimes it's just for holding information. Sometimes there is some process that it is going to do. It's being responsible for. And then the collaborations, basically, what other objects and functions is this object that we're going to talk about, this class? What is it? What other objects and functions is it going to involve itself with? So, with that said, let's get to the examples. So here we have on the front side of a CRC card, this would be class name old patient. I think what they meant to say was existing patient. I don't think they were trying to explain that it was an old person. So we have an existing patient. So this is a person that needs to receive or has received medical attention. That's what this object is. And so this object has to do the following things. It has to be able to make appointments. It has to be able to figure out when it last came in. It has to be able to change its status from either waiting on an appointment or in an appointment or having already had an appointment, and then also contain the medical history of the patient. Right, so those are the responsibilities that object has. And then the collaborators, it will be using or working with the appointment object or appointment class, and then maybe the medical history class. It will actually contain a medical history object with all of its information. And then on the back of the card, we're going to have the actual attributes of the class that we're talking about. So in this case, maybe an amount for how much the visit would cost, the insurance carrier, who is the insurance provider for that person, and then a list of the relationships that we've come up with. In this case, we know that an old patient is a kind of person. The person would be the parent class. It has the parts. If you have an old patient, it has a medical history, so it contains a medical history object. And then it's associated with the appointment object, which it's not a part of it, and it is not a part of the appointment object, and the appointment object is not a part of it, the old patient, but there is a relationship there, and so you mentioned that. And so you do this for all of the different objects that you can think of. Now, there's going to end up, for a big system, there'll be a lot of these. But you start out staying broad like this, just old patient, and these are the kind of things that we expect it to have. And then you go from there. So once you have created the CRC cards for your specific system that you're going to use, you can then do what's called role playing, not Dungeons and Dragons, no wizards, anything like that. It's not nearly as exciting probably as that. This is more you get the team into groups and they actually go through and act out the situations that these objects will find themselves in. So in the case of the old patient, one of the team members will then have to sit down and go through all of the different functions that an old patient would be expected to do, making an appointment, and changing the status and things like that, things that we just looked at. So you go through all of these and you see what happens. You see where things change. You maybe come up with problems. You find where the mappings that you have don't work, or where you're missing things, or where you maybe have extraneous information that you don't need. And so you do this, and you basically keep looking for and fixing problems and finding new information until you've decided that this is a good card. This has everything that we need. And then for all the remaining use cases that you have for all these objects, you keep going. You keep repeating and going through these use cases. It doesn't take as long as it sounds. It's mostly a matter of looking at the object and saying, does this object do everything that it needs to do? Can I get all the information I need from it? Can I get it to do the things that I want it to do? And then if you can, then you move on to the next object. So once you've done that, once you've created your CRC cards and you've gone over them and gotten them pretty much to where you think they should be, that's when we start looking at class diagrams. This is where we create a UML diagram that explains and shows visually the classes that we have come up with and how they relate to each other. So the classes, as we had mentioned before, these are the nouns. These are the objects within the system. And so that is going to be one portion of these diagrams. The other portion will be the relationships, which should basically be lines drawn between the classes, which have all that information, and then the other classes. So there'll be different types of lines depending on the kind of relationship that we have. And multiplicity, which I'll mention in the next slide, will indicate how many objects are associated with other objects. And that'll be clear in just a minute. But this is essentially what a class diagram is. It's classes, which are boxes, that like you had seen earlier, where they were separated into three different sections: the name of the class, the attributes of the class, and then the operations of the class. And then the associations between them, which will be the lines that connect the classes to each other. So when you are denoting the attributes of a class, attributes are essentially properties, variables, things that that class contains. A person, for example, would have a first name, a last name, an address, and then whatever else is necessary for that particular system. One thing that they mention in the book is that you can derive attributes, and that those attributes are preceded by a / that, like you see there. So what they mean by that is that you don't need to manually enter that attribute, that value, because it can be figured out. It can be determined from the other information that value that this class has. So, for example, you can figure out an age of a person based on the current day, the current date, and then their date of birth. You would just do a subtraction, and then you would have their age. So you can actually derive or infer that attribute information. So when you have attributes that have that ability, you use a / in front of them. And at the end of this discussion of a class diagram, you'll see a full class diagram, and I'll point out where these things are. The visibility is another thing that you will add to attributes. As a general rule with UML diagrams, a public attribute has a plus in front of it, a private attribute has a minus, and then a protected attribute has a pound symbol or a number sign. And so very quickly, quick visibility review. Public are visible to everything and everybody. Any class inside this system has access to these public attributes. Private attributes means the only class that has access to those attributes is the class that you are in. You can then create getter methods from within the class that are public, so you can get that information outside of that class. But the only class that has access to the actual attributes that can change them and that can see them in the first place is the class itself. And then the protected attributes, that means pretty much everybody but the outside world can see them. So the class is able to see these attributes. The package that the class is contained in can see the attributes, and subclasses of that class. So if a person class has a protected name, for example, a subclass of that person class, the old patient class, will be able to see that name attribute. It's protected, so people outside of the system can't see it, outside of that world, but people inside will be able to see it. And this labeling is basically to make it easy at a quick glance to determine what the information is contained in these classes and who has access to them and how they get used. So we're going to be using these symbols, and there will be more symbols as we go along. We'll be using them a lot. They're very important for presenting the information, because a lot of what we're doing is going to be creating a system and creating these diagrams to show to users, to show to people who are not involved in the design of this system, to be able to understand the system quickly. And using these symbols will help everybody. We'll all be on the same page. They won't need explanation of, oh yeah, that's a private attribute and that one's public. You just add the symbol in the front and it takes care of it. So operations are generally common operations. You're not going to show them. You're not going to be showing things like constructors, getters and setters for attributes, things like that. The things that you're interested in are specific actions that the class will take. So constructors, destructors, getters, setters, query and update are other terms for getters and setters. Those are not things that you're going to show. But you will show perhaps the make an appointment operation, because that is what affects other classes and is part of the functional responsibility of this class. So essentially, anything that is housekeeping, basically, of the class that you're in, you don't show, you don't list. You only list the things that impact and affect classes outside of the class that you are working with. And finally, relationships. The relationships are the lines between the classes. So, as I had mentioned, there are a number of different kinds of relationships. And the classes themselves are related to other classes. Sometimes they can be related to themselves, which can get a little funky. Like, for example, a manager and an employee. A manager is an employee, but a manager is also a manager. Where an employee can be an employee but isn't necessarily a manager. A manager has to be an employee but then is also part of the manager class. So it can get a little bit tricky with that kind of relationship, but mostly what we're worried about are the interactions between the different classes. So multiplicity, as I had mentioned earlier, it indicates how many of one class relate to another class, and there are many different combinations of this. And as an example, a one-to-one relationship, exactly one. So one department may have only one boss. So you would have one department, one boss. Maybe you have more than one employee within the department. So that would be a one-to-many, or a boss to an employee would be one-to-many. So the department really has to have at very least one employee, or it's not really a functional department. So that would be an example of the third one, of one to one or more. When you see that symbol, one and then a star, that means at least one, but possibly more. The second option, an employee may not have any children, or they may have one child or more, And so the 1 to 0 or more, it would be another relationship that you'd see. So notice they're not required to have one, but it's possible that they will have one or more than one. There's also, not shown here, the many-to-many relationship, which I'll explain in the next slide. So association clauses are common in the many-to-many. And by many-to-many, I mean you could have a number of objects that would relate to a number of other objects. Example they give here are students related to a course. So there are many students and there are many courses out there. And then there's a grade class that will show the relationship between the student and the course. So there'll be maybe 20 students in one course, each will have a grade, but then one student will also have 5 courses and have a grade in each course. So you've got a number of classes on either side of this relationship. That would be the many-to-many. And that is where association comes into play largely. We were saying that it's kind of like aggregation, but not really strong aggregation, and that's an example. The second example they give are illnesses related to symptoms. There are many illnesses, there are many symptoms, and a treatment would bridge the two. It would say here's the illness, here's the symptoms, and this is a treatment for this illness and symptom. So getting to the more specific kinds of relationships, generalization and aggregation. So generalization really does denote inheritance, implements, extends, those kind of keywords in programming languages. So it's saying that the properties and operations of superclass of the parent are valid, are inherited by the subclass. That's what the generalization relationship is showing. Now, when we have a generalization relationship, we have a solid line with an arrow pointing to the parent. So an employee will have an arrow, a line with a hollow arrow pointing to the person class, because the employee would be a subclass or a child class of the person superclass or parent. Aggregation is a logical part of, and what they mean by logical is that it's easy to add or remove. It's not an important specific part of the class. An example of that would be an employee for a department. So an employee is part of the department. So there are maybe 3, 4, or more employees inside the department. So the department contains a list of an array of employees. And they're easy to add and remove. And if you do remove all of them or add a bunch in, it's not going to change the department. The department will have more people in it, but it doesn't functionally change what the department is or does. And that's the logical relationship. Composition, on the other hand, is a physical part of relationship, one that's not, you can't just simply add and remove it. It's actually an integral part of the system. An example would be a car. A car has composed of 2 or more doors, and you can't just remove the door. That's part of the car. And if you do remove the door, then you've got a completely different car with different functionality. So you can think of aggregation as kind of a logical, not solid, not tangible relationship, where composition is more of a tangible, physical relationship. It doesn't always work that way, but that's a really good way to think of these types of associations. And here is a sample of the class diagram of the old patient appointment thing that we were talking about earlier. Now notice in the, I think it's participant class, there it is. You look down, you see on the age attribute, it has that / in front of it, meaning that age is inferred. That was it's not something that's been automatically entered. It's something that was gotten from the birth date and the current date. And then you can also see for the participant, all of the attributes are private attributes. And then looking down at the patient class just below that, you can see it has some separate additional information, the private variables, but also has a number of public methods. Now, the participant, you probably will have an add last name, or get last name, a set first name, a get first name, and so on. But we don't show any of those, like we were saying before. If it has to do with internal bookkeeping, we don't show it in the class diagram. But down in the patient class, you see make appointment, calculate last visit, change status. These are all things that have interactions with the other classes. And so those are the ones that we need to have displayed in the class diagram, because that's going to give us the relationships to the other classes. Now, this is all on Blackboard. I have all of the slides up there, so you can go back and look at this at a later time. This is also in the textbook too, though it's in black and white in my copy, not in color, for what that's worth. Now, I would like to point out that these class diagrams can get very big and very complicated very quickly. This is one simple example of one particular interaction, one particular use case. So the larger the system, these are going to get very large. And so there are a number of ways that people use to simplify class diagrams so they can show a larger portion of the system rather than one single use case like this. So there's a couple of ways that they handle this. One would be to only show concrete classes. So you're not showing all of those abstract parent classes like person or participant. You're only showing the ones that are going to be instantiated in the system. And that'll cut down a lot of the extraneous clutter that isn't necessary for people to understand the system. For the person designing the system, it matters, but to show the information to someone else, it's not as important. Another thing that people do is use what they call a view mechanism, which is basically filtering out certain classes and only showing maybe classes involved in one use case or another use case. Think of it like if you are browsing Amazon and you only want to see things in a certain price range, or maybe only Amazon Prime stuff. Those are the view mechanisms that we're talking about, where you're filtering out things that don't fall under a certain subset. And then the third option for simplifying is packages. If you're familiar with the Java use of packages, and I think C# does something similar to this, where everything is that is related to each other is aggregated into a package. And then that package is what's going to get shown in the class diagrams. So you can see how the different sections of a system interact, not necessarily the detailed interaction between the classes, but more of how this group of classes will interact with this group of classes. Really, it's up to the designer to determine how best to show these class diagrams and how best to show their system. So the second type of the static structure diagrams that we've been showing, the first one being the class diagram. The second type is the object diagrams. Now, these, instead of saying there's a doctor class or and then they interact with this is the actual class itself. We're actually going to instantiate a class and look at what it can do. We put values inside the attribute. We're actually on paper, we're actually instantiating some of these classes. And we do this to figure out the relationships in the attributes and see what we have and what we need. Because very often you will think you have everything. You have all the attributes, you have all the information you need, and you have all the methods that you need to use. But then when you actually instantiate it and look at it, you say, oh, I don't have his weight on here. I need his weight. So then you have to add another private attribute to the patient to include weight and height and things like that. So the object diagram is essentially the next step. Once you've created the class diagram, you create object diagrams to test all the objects, all those classes that you've created, to see if you have all the information you need. You may also find that you have too much information and that you need to remove some of the attributes. Maybe the weight isn't important in there. Maybe the weight is something that you'll store in the appointment or in the actual visit class, because that's something that will be specific to that visit, something that changes over time, and so you don't need to store it in the patient, you store it somewhere else, or something like that. Really, this is dependent on the system that you're creating. You're going to find different things, but the bottom line is you use object diagrams to find that information, to get all the concrete information and see what it's really going to look like when it's in use. And so here's an example of an object diagram. So the top part is just a copy of a section of the class diagram, but then the bottom section shows the object diagram. That is the object diagram. And you can see John Doe, he's got a name. We've got all this information. We've basically filled in all of the attributes that we have for him. And then the lines then will point to the relationships of with these methods that they're doing. So, and the other classes, excuse me. So John Doe has an appointment at 3 o'clock on this date, and he has a reason because he's a pain in the neck. So then the symptom that he has denoted here is muscle pain. Now, in this example of this diagram, you might see that, or you might come to the conclusion that the appointment has the reason, but really maybe that should be part of the symptom class, because the appointment is just really just the time and date and the place and when he shows up. But the symptom, that symptom object, the symptom class, that is what is the reason, and that's what's going to contain the information for the purpose of the visit. The appointment itself could just be the time and date and leave the reason separate. That's a judgment call. It would depend on how you would handle these other objects as you went along. Also notice that we've instantiated the doctor object, and so the doctor, who also is related to the appointment, right? Because the patient has the appointment with the doctor. So this is an association relationship. And so what we've done is we've talked about basically 3 different items that we use to help create this structured model. We've created the CRC cards, the class the reason and the collaboration cards. We have gone through them, reviewed them, checked for the things that we need are in there. We've done role-playing to test them all to make sure that we haven't missed anything, to look for problems and to fix them. And then once we're happy with that, we then go and create the class diagram based on the information we've gotten out of these CRC cards. And then you review the class diagram. Once you have it all, you can look at the big picture and then remove things that are unnecessary, add things in if they need to be, change the attributes and operations, fix relationships. The sixth step after that would be to look for patterns, look for things that get reused all the time. Like maybe the patient is interacting in some particular way with the doctor. And so that becomes a pattern. And then you take that, you can just lump it all into one large pattern, and that pattern can get placed in wherever it occurs throughout the entire class diagram. And then once you're done, there's the last step, which is new, one we have not talked about yet, and that is review and validate the model. And that'll be the last thing that we'll talk about here. So for verifying and validating, there's actually going to be a whole section on this in one of the later chapters. But really what you want to do is verify that what's on the CRC is in the class diagram. So each CRC is associated with a class, right? That's how we determine that these objects exist and these are the classes. So then you double check that the responsibilities on the front of the card are included in the operations, that the collaborators on the front of the card are included in the relationships and they're there. And then all the attributes that you have listed on the back are actually listed inside the class diagram itself. And then you continue, once you get the attributes for the data types, make sure everything is proper, whether it's visible or not, the kind of data type it is, and things like that. Then you talk about the relationship. You go and you make sure that the relationships are properly depicted, that you have the correct lines, the correct connections between the different classes, including the aggregation or the different kinds of multiplicity, the one-to-one, the one-to-many, and you include those into the diagram. And then just as a key point for all of this verifying, the association classes are only used to include attributes that describe the relationship between the other classes. So the association classes, like the appointment class, for example, is only describing the information that both the patient and the doctor need to know. That's the purpose of being there. So that's it. That is basically how we go about creating structured models. Now, these structural models are designed to give us a quick and concise overview of a fairly complex system, using UML to create the class and object diagrams, and using the CRC cards to help us determine what to put in these class diagrams. And then the verifying steps afterwards to make sure that everything that you have been coming up with, that you've then put into the class diagram. And so this whole thing, the CRC cards, the class diagram, the object diagrams, this makes up the structural model of a system. So that's it. Hopefully this won't have lasted too long. If you have any questions, please email me. I check my email regularly. Messages still are broken for what it's worth, so you have to bet on me checking messages, which I've been doing so far. But if you need to get a hold of me quickly, please email me. And that's it. I will look forward to hearing from you and seeing the work that you've done. And so that's it for the lecture for today. Hopefully this didn't last too long. Let me know if you like these. If you like seeing a short lecture on the material, I can do more of these for you if it'll help. I know the independent study can be a little bit difficult to know what to focus on and how to know what you really want to get out of the class. And so this particular chapter I thought was important enough because this has a lot of material that you're going to be actively working with. So I thought I would do this for you. But if you like this, if this is something you'd like to see more of, please let me know. You can email me. You can leave a message. I'm checking them every day until I can figure out how to get them to forward to my email. And so, yeah, let me know if you like them, because it takes a little bit of time on my end. But if it's going to help you with the material and help you throughout, get this project off the ground and working, then I'll be happy to do it. So, Okay, let me know. And as far as the rest of the week, take a look at the assignment that I finally got properly posted, and that's it. That'll be due this coming Sunday. All right, have a good night.